Have a nice day, students. Welcome to Conceptual Chemistry. In this section, we are going to discuss the trends in modern periodic table. What are the various trends which is observed in the periodic table? First trend, atomic radius. What will happen to the atomic radius when you move from left to right and top to bottom? We know the atomic radius definition, the distance between the center of the nucleus to the outermost valence electron, that we can call as the atomic radius. So what will happen to the atomic radius when you move from left to right? So by seeing here itself, it will be one thing. It will be clear. When you move from left to right, the size it will be keep on decreasing. Here it will be more, and it will be keep on decreasing. And when you move from top to bottom, the size it will be increases. So what is happening? So how the size it will be decreases? Now see, students, if I take the second period, in the second period, the number of the shell it will be same for the entire element. So the number of the shell it will be 2 only. It will be 2. When you keep on moving, it will be 2 only. The shell, 2 shell only, but the number of protons it will be keep on added. The number of protons it will be keep on added. Here if it is 2 means here it will be 3, and here it will be 4, and here it will be 5. When the proton, when it is keep on added, the size of the nucleus it will be increases. So when the size of the nucleus when it increases, then the atomic radius it will be decreases. That is the reason. When you move from left to right, the atomic radius decreases because of this reason only. Same shell, number of protons increases, so the nucleus size increases, and when we measure the radius it will be decreases. So atomic radius it will be decreased when you move from left to right. What will happen to the top to bottom? So when you move from top to bottom, the shell size it will be increases. 1 shell, 2 shell, 3 shell, 4 shell. Like this shells, the number of shells also it will be increases. At the same time, the number of protons also it will be added. Protons also it will be increasing only. But the shells also it will be increasing. So when you measure the distance, here if I measure the distance, here the distance, you itself you can identify the distance. It will be at the 1 shell, the distance it will be less. 2 shell it will be more. 3 shell it will be little bit higher. 4 shell, the atomic radius it will be more. So when you move down the group, the atomic radius it will be increases because the number of the shells it will be increases. So this is the reason. So in this slide, we want to understand atomic radius. When you move from left to right, it will be decreases. When you move from top to bottom, it will be increases. And one concept we want to note here. When you see the D block elements, we know that here S block element is there, P block element is there. The center part, it will be the D block, and the bottom part, it will be the F block. So the D block element, if you see the atomic radius, more or less it will be like look like a similar. Why? Why it will look like a similar? And there will be a gradual increase. It will be there, but it will not be very rapid increase. There will be a gradual increase when you move from top to bottom. You can, even if you move from top to bottom also, there will be not be rapid increase. Yes, gradual increase is that. If you compare the S block element and P block element, you can observe this in the D block element. Why the D block element, the atomic radius more or less it will be like a similar? What is the reason? The reason is shielding effect or screening effect. So what is the meaning of shielding or screening effect? The shielding effect, it describes the balance between the pull of protons on valence electron and the repulsion forces from inner electrons. If you want to understand that, see this diagram, students. So here the center part, the yellow color part, it represents the nucleus, and here the inner electrons is that, and the outermost valence electron is that. This is the outermost electron. Now what is the meaning of shielding effect means? The nucleus, what is the nature of the nucleus means? It will attract the outermost electron. That it will do. It will attract the outermost electron. When it attracts the outermost electron, the electron which is present in the inner shell, which I quoted in the blue color. See here, the electrons which is present in the inner shell, it will repel. When it try to, when the nucleus attract, this electron will come close. When it come close, this electron repulsion will be there. Electron repulsion will be there. Like in the magnet, how the north pole it will be reflect like that. The same thing, repulsion it will be there. Same pose it will be repelled. Like that here also, the electron repulsion it will be there. So it will not contract. So that process we can call as a shielding effect. So if the inner electrons, if it is more, then the shielding effect also it will be more. So more number of inner electrons, more number of shielding effect it will be there. Less number of inner electrons, then less number of shielding effect is there. So here in the shielding effect, we want to know the nucleus and the electron, the attraction will be there, and when the nucleus and electron attraction is there, at the same time the electron repulsion also it will be there. So two things will be happen. Sometimes the nucleus attraction will be greater. When the nucleus attraction will be greater means when the inner shell, if it contains less number of electron, then the nucleus to the electron, the attraction will be greater. At that time the contraction take place. At the time the contraction take place. That means when the nuclear force of attraction is greater than the repulsive force, at the time the contraction will be take place. Sometimes there, if more number of inner electrons is there inside, then the repulsion, electron repulsion will be more than the attraction. At the time the contraction will not be take place, only the expansion will be take place. So the atomic radius it will be increases. Now we come to the concept why the d block element will have the same, and we want to know the s orbital will have a more screening effect than the p, and the p orbital will have a more screening effect than the d, and the d will have a more screening effect than the f. So this order you want to remember, because the shape of the s orbital it will be spherical, and the p orbital it will be a dumbbell shape, and the d orbital it will a double dumbbell shape. A double dumbbell shape is there, like this, a double dumbbell shape, and f orbital it will be a diffused one, so very diffused one. So due to this, the d orbital it will have a poor shielding effect. The d orbital it will have a poor shielding effect. So when it have a poor shielding effect, what will happen? When it have a poor shielding effect, the nuclear force of attraction to the outermost electron it will be more. So it will attract and the contraction take place. When the contraction take place, then the nuclear size it will not be increases. It will look like a similar. That is the reason the d block elements, because we know the d block element, the outermost electron it will be it will enter in the d orbitals. In the s block element, the outermost electron it will be enter in the s, like 1s2, 1s1. If you take the sodium also, the outermost electron if you see means it will be 1. If you take the p block element, the outermost electron it will be filled in the p. In the d block element also, the outermost electron it will be filled in the d. So the d it will have a poor shielding effect. Due to the poor shielding effect, the contraction take place, and the size it will not be increased. That will be gradual, same, it will look like a same size. That is the reason. Then we want to know one more concept also in the trends, the effective nuclear charge. What is the meaning of effective nuclear charge? If you have the atom, the center part, we know that nucleus. So the net positive charge, which is experienced by the valence electron, that means the outermost electron, how much nuclear force of attraction it is experienced, that we can call as the effective nuclear charge, and it's represented by the symbol, ZeFF. This is the representation of effective nuclear charge. And if you want to calculate the effective nuclear charge, by using this formula we can calculate. The Z it represents the atomic number, and X it represents the shielding effect. For example, we can take the fluorine. Fluorine atomic number it will be 9. So we can write like this: 1s2, 2s2, 2p4, 5, 2p5. So in the second shell, how much electron is there, students? So if you want to draw the structure means it will be like this. So in the first shell 2, and the second shell 7 is there. 1, 2, 3, 4, 5, 6, 7. Okay, 7 is there. So the center part, the nucleus it will be there. So if you want to find the effective nuclear charge for the fluorine, what I want to do means atomic number. What is the atomic number? Z here 9. The shielding effect. What is the meaning of S? The shielding. That means how much electron shielded the nucleus. How much electron shielded the nucleus? Don't take the outermost electron. See that in the inner shell you only want to take it into count. So 2 electron it is shielded. So 9 minus 2. So how much it will be? 7. So the effective nuclear charge for the fluorine it will be 7. Like this we can calculate for all the elements also. This is one example. The next concept, the next trend is ionization enthalpy. What is the meaning of ionization enthalpy? First you want to know the meaning. Ionization enthalpy means the amount of energy which is required to remove the outermost electron. The amount of energy which is required to remove the outermost electron. For example, here there is consider this as one atom. Here one outermost electron is there. Here one outermost electron is there. And we know that the center part, the nucleus, what is the nature of the nucleus? It will attract the electron. Okay. Now I want to remove the electron. I want to remove this electron. when we trying to remove this electron, how much energy is released? When we trying to remove this electron, how much energy we require to remove this electron? How much energy is required to remove the electron? That we can call as ionization enthalpy. So the ionization enthalpy, when it will be more, means what will happen when it move from left to right? When we move from left to right, now only we discussed at the beginning. What we discussed in the beginning, atomic size. What is happening, students? Atomic size, what is happening when you move from left to right? It will be decreases, that is small. When the atomic size is small, who will be greater means the effect in nuclear charge. The effect in nuclear charge, it will be greater. When the effect in nuclear charge is greater, what will happen means the nuclear force of attraction. The nuclear force of attraction, it will be greater. The nuclear force of attraction will be greater. So I can't remove this electron that much easily. I want to supply more energy. I want to supply more energy to remove this electron, because more nuclear force of attraction is there. If the size is small, more nuclear force of attraction is there. So I want to pass more energy. So when the size is small, the ionization enthalpy, it will be more. So when I move from left to right, ionization enthalpy, it will be increases. That is the concept you want to remember. Again I am repeating, ionization enthalpy, when I move from left to right, it will be increases, because size decreases. When size decreases, the nuclear force of attraction, it will be greater. So I want to supply more energy to remove the electron. What will happen to the ionization enthalpy when you move down the group? When we move down the group, what is happening? When we move down the group, we know the shell size, it is increasing. The shell size, it is keep on increasing. When the shell size keep on increasing, what will happen? The nuclear force of attraction, it will be decreases, because more shell means, we know that only we discussed in the beginning itself in the atomic radius also. So when the shell size increases, the nuclear force of attraction, it will be less, because the distance, it will be more. The distance is more, so the nuclear force of attraction, it will be less. At the time, I can remove this electron very easily. That means less amount of energy I will supply to remove this electron. So the ionization enthalpy, when I move down the group, that means when I move from top to bottom, ionization enthalpy, what is happening? It is decreases. When I move from top to bottom, ionization enthalpy decreases. The reason is the size increases. So the distance between the nucleus and the electron increases, and the nuclear force of attraction decreases. So I can spend less amount of energy to remove the outermost electron. So in this slide, we want to understand ionization enthalpy. When you move from left to right, it will be increases, and top to bottom, it will be decreases. The next one, metallic character. What will happen to the metallic character? This everyone you know. So in the left hand side, more metals will be there, and the right hand side, non-metals will be there. So when you're writing, at the time you want to mention, when you move from left to right, the metallic character, it will be decreases. When we move from top to bottom, metallic character, it will be increases. So this is the metallic nature. Then another concept, another trend, electronegativity. What is the meaning of electronegativity? The tendency of an atom to attract the electron towards itself. For example, in a molecule, that is very important, in the molecule. For example, if I take a HCl, so in the HCl, what will happen means, the hydrogen also has one electron, and the chlorine, it need one electron. We know that the chlorine, it need one electron for the octet configuration. So it always attract the electron. So it will attract the hydrogen electron towards itself, because it is more electronegative. It will always attract the electron towards itself, because it needs the electron. So it will push the electron towards itself like this. So the electron of the hydrogen electron, it will be very close to the chlorine, like this it will be. So this property we can say to be electronegativity. In the molecule, we can see that electronegativity. So this picture also, it will help you to understand how the chlorine, it will pull the electron from sodium, and sodium, we know that it want to lose one electron to attain the stable configuration, so it will give it. Then electron affinity. What will be the electron affinity? The amount of energy liberated. The amount of energy liberated when electron added to neutral atom. When electron added to, so when electron is added to the neutral atom to form a negatively charged ion, that we can call as a electronegativity. So the electronegativity we discussed, this is the electron affinity. So electron affinity values increases from left to right. So what is the electron affinity? The nature of the element. What is the attraction of the element to the outermost electron? That we can call as the electron affinity. So when you move from left to right, we know, what we know means the size, it will be decreases. When the size decreases, the nuclear force of attraction, it will be more towards the electrons. So it will be increases. The electron affinity value, it will be increases when you move from left to right. But when you move from top to bottom, what we understand, then shell size it will be increases. When the shell size increases, the nucleus and the outermost electron, the attraction it will be less. So the electron affinity it will be decreases. So this also you want to remember, students. This is one more important concept. So this diagram it explains that atom, in the neutral atom we are adding the electron. So if it is more, if it needs electron for the octet configuration, it will gain and it will become negative charge, because gaining it will get negative. Then one more trend, electron gain enthalpy. What is the meaning of electron gain enthalpy? Electron gain enthalpy, it will be similar to the electron affinity, but both it will not same, it is different. Electron affinity is not equal to electron gain enthalpy, but it look like a similar. I will say what is the difference between the electron affinity and electron gain enthalpy. So electron gain enthalpy is the amount of energy released when an electron is added to the isolated gaseous atom. That is very important. Isolated gaseous atom. During the addition of an electron, energy it can release or it will absorb. So here we want to remember, there is a shell in an atom, in an isolated gaseous atom. I am adding electron. When I added electron, two possibilities are. What are the two possibilities? Means it can release electron. It can release electron, at the same time it can absorb electron. So two things it will be happen. It can release or it can absorb. So when it release, it will be exothermic reaction. Then it will have a negative value. The electron gain enthalpy it will become negative value when it release energy. When it absorb energy, the electron gain enthalpy it will become positive value. So you want to know this. This is the types. So electron gain enthalpy, there is a two types: negative electron gain enthalpy and positive electron gain enthalpy. So two things is there. You want to understand this. When it will be negative, when it release energy, when you are adding the electron, then it will be negative. When it will be positive, when you are giving energy to add the electron, then it will be positive. Okay, for your understanding, I will take one example here, students. If I take the helium, you know helium, what is the outermost electronic configuration? 1s2. That means in the shell, in the s orbital, the two electrons it is fully completely filled. Now in this helium you are going to add one electron. Listen carefully. In this helium you are going to add one electron. Now you can't add the electron because the shell is already fully completed. Now you want to add this electron in the next shell. So what you want to do, you want to give some energy to this electron to place the electron in the new shell. At this time it will have a positive electron gain enthalpy. So for all the noble gas now, if you see, means it will have a positive electron gain enthalpy, it doesn't have negative electron gain enthalpy. So negative electron gain enthalpy means, you take this example here. Here's the picture. From this picture, one is the sodium, one is the sodium and another is the magnesium. See, this is the sodium and this is the magnesium. Now we are going to add one electron. We are going to add one electron. So which atom it will absorb the electron very easily, and what type of thing will happen, whether it is release or it will be absorb energy, that only we are going to discuss. In this two, in the sodium and magnesium, which will absorb the electron very easily? You have any guess? Now see here, when we add electron here for the two element, which will attract the electron more readily means the magnesium, it will attract the electron more readily. Why means, because we know, we discussed one concept, when we move from left to right the size decreases. The sodium, when I compare to the sodium, the magnesium size it will be small. When the magnesium size is small, it will attract the outermost electron very easier, readily. So this electron it will be more readily added to the magnesium compared to the sodium. When it added to the magnesium in the shell, more energy it will be released, so it will be more negative value. So what is the meaning of more negative value? Means the magnesium it will readily attract the electron, so it will have a more negative value. Sodium also it will attract, but it will be take less, it will have a less negative value. It will not be like that sodium, because magnesium it will be less in size, so the attraction it will be more readily compared to the sodium. Sodium it takes, it will be less negative. The reason is it will not attract the electron that much readily compared to the magnesium. So this is one more concept. So in this slide, what you want to understand means, what is the meaning of electron gain enthalpy? Electron gain enthalpy is the amount of energy released when an electron is added to an isolated gaseous atom. And here not only release, even the absorption also takes place. When we are adding the electron, two things will be happen. Energy it will be released or energy it will be absorbed. If it is released means, we will say that as exothermic and it will be negative value. If it is observed means you will say there is a endothermic and it will be positive value. And now I will say the difference between the electron gain enthalpy and electron affinity. Electron affinity, it is the attraction of the element, students. It is the nature of how the element it will attract. We know that affinity, what is the meaning of affinity? Means love. So the element it will be lovable for the electrons, that we can call as a electron affinity. But here electron gain enthalpy, it will talk about the energy released, whether it will be released or it will be absorbed, and the values. So that is the difference between the electron affinity and the electron gain enthalpy. Then the last trend, valency. So this we everyone we know that when you move from left to right, what is happening? The valency it will be increase, then it will be decrease. So it will not be same. We want to know the definition for the valency. Valency is defined as the combining power of an element with other atom to form a chemical bond. So in group, when you move down the group, the valence it will be same. For example, if you take the first group, it will have the same valence, 1 1 1 only. If you take the second group, the valence it will be 2 only. If you take the third group, the valence it will be 3. So when you move down the group, the valence it will be same. When you move from left to right, the valence it will be increase, then it will be decrease. So in the entire section, we discuss the trends in the modern periodic table. Like, share and subscribe, students. Thanks for watching.